we're going to finish from yesterday. So unfortunately, yesterday was cut in half because of what's that called? Personal project. So we didn't get through this. The good news is now today should be pretty simple. So we're finishing the notes from yesterday. By the way, I can't believe nobody commented on me not having a mustache anymore. No one? It's like my face is naked.
You did warn us it was going to be going soon.
That's true. So as soon as I shave it, it's like shocking how I look. And as soon as the first time it gets kind of long, I've just looked so different with it and without it. I kind of like a little 5 o'clock shadow. I think that's my best look.
Yeah, I thought I joined the wrong class for a second this morning because I didn't recognize you.
Who is that kid teaching our class? I'm just kidding. Not a kid. I know, I do. I look like two completely different people. All right. So with quadratics, again, you guys should be pretty comfortable with quadratics. You've done this for a long time. Your vertex is going to be at HK. So again, the H always moves it left to right. The K moves it up or down. If A is greater than 1, it stretches it. If it's less than 1, it shrinks it. Now here's the thing. A stretch, kind of like a rubber band, a stretch is going to go up a lot quicker. This is what a stretch looks like. What a compression looks like is it's going to be a lot wider. So we might have compressions that look like this. Again, you can always plug and chug, but start at the vertex and understand how things are being shifted or moved. If it's negative, instead of opening up, it's just going to open down. That's the biggest difference. All right. Again, think about this and what makes it. So on Monday, we're going to really start talking about domain and range, but there's nothing that limits what X can be. X can be positive, it can be negative, it can be 0, it can be anything. So right here, my parent function, as always, if you're not sure what it looks like, let's just fill in different values. So if I fill in -2, -2 squared is +4, -1 squared is +1, 0, 1, and 4. So on and so forth. And this makes a shape called, does anybody remember what that shape is called? I might even have said it.
A parabola.
A parabola.
Perfect. By the way, we don't get too far into this semester because we're really going to study parabolas at the beginning of trig next semester. So that's what it looks like. So all I want you to do here is find your vertex, describe it, and graph. By the way, I'm going to teach you or show you again a faster way to graph these. And I do want to actually, before we go too much further, I want to compliment you guys on how you guys submitted the assignments. I got everybody submitted except for 3 of you guys through Canvas, through the assignment. 3 of you emailed me, which is fine. It's still preferable through the assignment. But you emailed me, and everybody, almost everybody, either printed it out or they downloaded it and wrote on the PDF. Guys, that's fantastic. It's probably easier to do and it's easier to grade. But I kind of like doing that. So number 1, let's describe the transformation, or let's find the vertex first, then we'll describe it. What is my vertex for this first one?
Right 2, down 1.
Perfect. And I heard somebody else say 2, -1. 2, -1 is your vertex, which means it's been shifted right 2 and down 1. What's this 2 done to it?
Stretch.
Perfect. And we would say it's been stretched by a factor of 2. Stretched by a factor of 2. Now, really, if we were describing this, we need to describe it from left to right. So I'd say it's stretched by a factor of 2, moved right 2 and down 1. Because if I follow everything up by saying it's stretched, then I'd have to multiply everything by 2. Well, here's what this looks like. My vertex is the point 2, -1. Now, some of you guys were taught really well about the A value. We have an axis of symmetry. Guys, we're not going to get into all of this stuff with it. You could either make a table. You could always make a table. Where your vertex is in the middle, so I'd start with 2, -1, and then just make this look like a number line. So I could plug in 3 and 4, 1 and 0, and plug and chug. But let's go ahead and plug this in, and then I'll explain when I say what some of you are taught well, looking at your A value, I'm going to explain that to you real quick after I do this. These values, if it's an equidistant step, to step 1 both directions, means your Y values have to be the same. So if I plug in 3, 3 minus 2 is 1, 1 squared is 1, times 2 is 2, minus 1 is +1. If I plugged in 1, it'd be the exact same thing. 1 minus 2 is -1. -1 squared is 1. 2 times 1 is 2, minus 1 is 1. And let's plug in 4. 4 minus 2 is 2. 2 squared is 4, times 2 is 8, minus 1 is 7. So that has to be 7. So I got 3, 1. 4, 7. There you go. By the way, does anybody remember how to graph this without making a table, just using the A value? No. Okay. So here it is. You have a simple equation. The squared is what helps you remember this, but as always, your horizontal steps squared. So your number of horizontal steps squared from the vertex. Times A equal the number of vertical steps. Now, that seems like a lot to remember, but if you just do this a couple times, I promise it's really not that bad. And by a lot of things to remember, here's what we're going. So we knew that our vertex was at 2, -1, right? Let me erase this here. And that's also kind of showing the importance of the axis of symmetry. Again, we're not going to get into overkill on quadratics. We could talk about quadratics for a month. But from this point, 2, -1, if I take one horizontal step from the vertex and I square it times my A value here is 2, that's going to tell me how much I go up or down. 1 squared is 1 times 2 is 2. So one horizontal step means I go up 2, but again, both ways. if I took 2 horizontal steps, square it times A equals my number of vertical steps. 2 squared is 4, times 2 is 8. So 1, 2, up 1, 2, 3, 4, 5, 6, 7, 8. And then 1, 2, 1, 2. It's a much, much, much faster, easier way to do this. Any questions about that?
So are you
Say that you squared the x.
So you square, right. So the same thing, you want to square your number of horizontal steps, again, from the vertex. So if I took 3 steps from the vertex, 3 horizontal steps, 1, 2, 3, how many vertical steps would I have to take? Well, 3 squared times whatever your A value is, and I'd have to take 18 steps up, so I'd be way up here. Does that make sense? 1, 2, 3, I'd be way up here. So it's actually a really simple thing, and it's the same thought process that goes with making a table. Now, let's do this again. What's my vertex here on number 2?
Is it -1, 3?
Perfect. So -1, +3. Now let's describe the transformation. So what's this negative out here done?
reflected?
So it's reflected over the x, which means it opens down, right? And it's moved.
Right 1?
Right? It's negative,
So left 1,
left 1,
and then up 3.
up 3. So this is basically just tying together all of the h and k. It's always, always, always the opposite of what's happening to x. That's your h value, and then k's out here. So left 1, up 3, and I know it opens down. Well, let's try that little trick I just showed you, and it's not a trick. It's mathematically sound. It's what it is. So if I want to take 1 horizontal step, 1 squared times a, what's my a value here?
-1.
So 1 squared is 1 times -1 means if I go over 1, I go down 1, and that has to be both ways. If I go over 2, how many vertical steps do I take?
Is this if you were trying to plug in like different x values to get the other points?
This is instead of making the table. So from the vertex, from right here, if I take 2 horizontal steps, all I have to do is square it. And the horizontal means left and right, right? Is square it and multiply by my a value. So 2 squared is 4 times my a value, which is -1, is -4. So again, here's my axis of symmetry. If I take 2 steps right, I have to take 4 down. 1, 2, 3, 4. 1, 2, 1, 2. If I took 3 horizontal steps, square it times -1, I go down 9. So 1, 2, 3. 1, 2, 3, 1, 2, 3.
This is for the original parabola, right?
This is for this parabola. Remember, the original one, the parent function, was this. So what's happened is we moved the vertex left 1, or we flipped it upside down, then moved it left 1, up 3. So you just kind of have to know the basics of everything about it. I'm getting into a little bit too much detail, but I just want you guys to understand what's going on. So a lot of times we forget how to graph, and that's actually a big part of the SAT and ACT is making sure that you know a little bit about everything. That's what the ACT and SAT are all about. So when you forget, because inevitably you will, you can always just make a table. But how do you start the table? Well, you have to find what your vertex is, and that's where you start. Questions?
Yeah, I still don't get like, so I know what you mean by the vertex, but like, how did you know what numbers to, like for the 1 and 2? Yeah,
Yeah.
like how did you know to put those numbers down there?
I can pick anything I want, Larry. Anything. All right, let me erase this real quick and I'll show you what I mean. So those are the number of horizontal steps that I want to take. Now, let me just say, when you're graphing, do you want to take 10 steps or would you rather take 1 step? For instance, what if I had this? So if I have that, where's my vertex real quick? What point, where do I even start this at what?
-4, 7.
-4, 7. That's my vertex. And does this open up or does it open down?
It opens down.
Right, because A is negative, okay? So all I have is my vertex. I can choose how many horizontal steps I want to take. So why I could pick numbers like 7, 8, 9, 300. I want to know my next point to the left and to the right of this, right? So if I take 1 horizontal step, I have to square it times whatever your A value is. And that's how many vertical steps we take. So if I go 1 to the left or right, I have to go down 1, 2, 3. There we go. Now, if I took 2 steps from the vertex, 2 steps over, so I'm basically finding that other value. If I took 2 steps over, 2 squared is 4 times -3 is -12. So from the vertex, if I go over 2, I go down 12. And that's how you do this. Now, if I would have picked, and I would almost always, and I'm saying almost always, pick just 1 and 2 steps, Larry.
Okay, just to make it simple.
Yeah, exactly. Now, I'm going to show you a case where I would not just pick 1 and 2 steps. Oh, come on. So what's my vertex here?
-1 minus 2, or
+1. Negative.
yeah, that's what I mean. Yeah.
So here's the thing. Now I would not take 1 step. Because if I took 1 horizontal step, 1 squared is 1 times A, it would give me a half vertical step. So that's the only time that I would not take whole steps of just 1 and 2. So instead of 1, how many steps do you think I should take? And the answer is all multiples of your denominator. If you ever have a fraction, then I'd want to take 2 and 4. That way I don't have something like, oh, write 1 up a half or write 1 up a third. So 2 steps squared times 1/2. So 2 squared is 4 times a half is 2. So right here, if I took 2 steps, I'd go up 2. If I took 4 steps, squared is 16 times a half is 8. So if I took 4 steps, 1, 2, 3, 4, I have to go up 8. And you can see anytime it's been compressed, or shrunk, I want to take steps in multiples of the denominator.
Okay.
All right. Now, if I would have picked 1, it would have been fine. 1 squared times a half is going to give me 1/2. So if I took 1 step over, I'm up a half. 1 step over, up a half. It just gets too crammed, but I'd end up with the same numbers. All right.
Okay, thank you.
You're welcome. All right, so let's go on to the last type, which is cubics. Now, again, H and K, H still moves it left to right, K still moves it up or down. So your parent function, I'm not adding or subtracting anything. So my vertex is at 0, 0. Now, make a table. 0, 0 is going to be in the middle. Let's pick things like -1, -2, 1, 2. So anytime you start to get confused on this, again, it's going to happen. It happens to all of us. Make a simple table, plug those values in, and get kind of a visual of what it looks like. -2 to the third is -2 times -2, which is +4, times -2, which is -8. Again, you can just type this in your calculator. Make sure you use parentheses. -1 cubed is -1 times -1 times -1. Thank you, Robert. I got your email. 1 cubed is 1 times 1 times 1. 2 cubed is 2 times 2 times 2. There we go. Now, this has symmetry, which we'll explain later. 2, -8 is down here. So this is actually has symmetry about the origin. There you go. By the way, if this is being stretched, if you have a coefficient for A that's greater than 1, what's going to happen is that first step is just going to go up a lot quicker. So a stretch of this would look something where it looks like it's less of a turn. It would look something like that. A compression would be something like this. Any questions? All right. So let's get going with this. I just want you guys to find a couple points. Now, there's no hints or tricks or anything else here. Start with your vertex and put a couple other points up here. Number 1, what's your vertex?
Four, -1.
My vertex is 4, -1. It has not been stretched or reflected or compressed. So again, if we're making a table, that vertex always goes in the middle. So 4, -1, I want values again directly left and right. But these are going to be different. So this is how you can do this anytime. Again, you can always use your calculator, guys. In fact, from here, I'm going to go ahead and use our calculator. Sorry, how close and personal. So I believe it was x minus 4 cubed minus 1. So parenthesis x minus 4 caret button to the third hit over minus 1.
You can't really see it.
I'm sorry. Let me pin my video. That's why I always pin my video, because I can't see you if you guys can see it or not. Come on, let's go. What is going on? Why did it, oh, you know what? I need to turn my light on. That's probably why. Can you see now? Yep, perfect. All right. So you can always type that in. Oh. You can always type this in. Again, to get to the third, you hit the caret button, this one right here, that up button. Type in the 3 and then make sure you hit the over again. Once you're there, you can graph it and that should show you what it looks like. By the way, don't just trust your graph. If you hit second table and make sure you know where the vertex is. So remember, your vertex was at 4, -1. So these are the points that you would plot. Again, this is really all about knowing your vertex and how something is moving and what it should look like. Now let me share my screen and let's do the other one. What is my vertex here? Anyone? What's the vertex?
0, 0.
I heard 0, 0. Is that correct?
0 plus like 0, 3. I mean,
0, 3. There you go. 0, 3 is right. So your vertex is 0, 3. This has been stretched. So again, if you're confused, go to y equals 2 hit the right button, and then was it plus 3? So you have to know what your vertex is. Because I promise you, just putting that on your graph, kind of slopping it up, especially when we get back, isn't going to work for me. You're going to have to show me the points. Not make a table, but show me the points. So how do you get the points? It's second graph, that's your table. You said your vertex was a 0, 3, so I need points on both sides. So I should have one at -1, 1, -2, 13, 1, 5, and 2, 19. And that's it. Any questions? By the way, I want you to see something real quick. I can't believe I didn't put something up here. Let's change this to like negative x cubed plus 4. So the negative is right below the 3. And see what happens. What happens when your a value is negative? So what does a reflection over the x-axis look like? When you do that, notice it was going from low to high. Now it's going from high to low. Does anybody have any questions? Robert, let me make sure I got this. Guys, you do have an assignment. Let me share my screen one last time. It's up on Canvas, but I'm not sure. It still might be under last night's homework. So you have an assignment. It's on the one. I don't think I adjusted it for today, but it's just 6 questions talking about the graphing, the vertex, the shifting, the transformation, so on and so forth. Monday, when you get in here, we are really going to focus on domain and range. All right. We are finished. You guys have a wonderful weekend. Stay safe out there.
Thank you.